Hello students, hope you are doing well. This is Suryam, Assistant Professor, Department of Pharmaceutics, Vishnu Institute of Pharmaceutical Education and Research. Today we are here to discuss the measurements of surface and interfacial tension. The surface and interfacial tensions will be determined by different methods. Those methods are capillary rise method, Dunoy ring method. This Dunoy ring method is also known as detachment method, drop weight and drop count method. This drop weight or drop count method is also known as stalagmometer method. Maximum bubble pressure method or bubble pressure method. Maximum bubble pressure method and Wilhelmy plate method. So these are the different methods are there to determine the surface and interfacial tension. In these methods, especially the capillary rise method and Wilhelmy methods, these are the methods only determine the surface tensions. And remaining this Dunoy ring method, drop weight and drop count method and maximum bubble pressure method, they are used to determine both surface tension and interfacial tension. Drop weight and drop count method also used for to determine the surface and interfacial tension, and maximum bubble pressure method is also used for surface and interfacial tension. Let us discuss these different methods in detail one by one. The first one is capillary rise method. So in this method, generally we will be having a capillary, and in this capillary, due to the surface tension, the sample will be rises upward direction, and when the countering force is attacked to the same liquid sample, then again it will be going to stop. Thus we can calculate or we can determine the surface tension of the particular sample. The principle involving in this capillary rise method is when a capillary tube is placed in a liquid, the liquid will rises in the tube due to surface tension acting along the circumference of the tube's contact angle. Based on this principle, the capillary rise method is going to work. So that means if you observe this diagram, we need to dip a capillary into the sample like this. So when the capillary is introduced into a sample, then when we introduce the capillary into the sample, then the sample or the liquid will rises in the capillary tube. This happens because of surface tension. The surface tension is happens because of the surface tension. As we discussed in the previous lectures, the surface tension happens because of involving of the adhesive forces. Here the adhesive force will be acts in between the liquid sample and the wall of the capillary tube. This force will be known as adhesive forces. Because of this adhesive forces, the surface tension will be increases. Because of the surface tension is increases, the sample in the tube will rises. In this capillary rise method, the force will acts in two different directions. First direction is upward direction, and the second direction is downward direction. At this upward direction, the surface tension will be more because of the adhesive forces. Because of the adhesive forces. This downward direction, at this downward direction, the countering force will be involving. The countering force. So the countering force will be in a form of gravitational force. During this downward direction, this gravitational force or countering force is completely depends on the density of the sample which we are trying to determine. Let us discuss what happens at upward direction and what happens at downward direction in detail. First, at upward direction, in this process, first thing we need to do here is we need to clean and dry the capillary tube, and in the second process, now fix it to a stand and attach to a movable microscope to observe certain height of the liquid up to which height it is raised, and also to observe the contact angle. The contact angle is known as the contact between the liquid sample and the walls of capillary tube. And this is denoted by theta. Now dip the capillary into the liquid sample Now note down the contact angle theta and the appropriate height of the liquid which it is raised up to. After this process, calculate the density of the sample, and this density of the sample will be calculated by specific gravity bottle. This specific gravity bottle is also known as pycnometer and also known as density bottle. By help of specific gravity bottle, pycnometer or density bottle, we can calculate the density of the particular liquid sample which we are going to use in the experiment. Now we need to consider the force which is acts during the rising upward direction and the circumference of the liquid A, that is considered as gamma cos theta. This is equation 1. In this, gamma is surface tension of liquid, cos theta or theta is the contact angle between liquid and the wall of capillary, and this is in case of a single circumference. But in this experiment, the capillary rise method will be moving, the rising of the liquid will be moving upward direction, and when the countering force is attacking to this upward moving force, then we need to consider here two circumferences. As per this capillary will be having two circumferences. Hence, the equation 1 can be written as two pi r gamma cos theta. Here 2 pi r is inside and outside circumference of capillary tube. Again, cos theta is refers the contact angle, and also gamma is refers as surface tension of the liquid. The contact angle of water sample theta will be 0. So if you substitute the theta value in this equation, in case of water sample, by using this equation we can calculate the surface tension of water sample. In case of other samples or other liquid samples, the contact angle will not be 0. So let us consider this equation in other samples. So for in case of other samples, the surface tension will be calculated or measured by this equation. Anyhow, we are considering water as the sample, so the equation will be 2 pi r gamma. This will be the equation number 3. So at upward direction force, we have the surface tension formula at upward direction, that is A is equals to 2 pi r gamma. Now let us see what will happen at downward force in the capillary tube. So as we discussed, at this downward force of capillary tube, a countering force is going to involve. Countering force in perspective of gravitational force. Here a countering force, and that countering force is gravitational force. As we discussed, this countering force as gravitational force is completely depends on the density of the sample. Now let us go in detail about this downward force where the countering force is acting in the capillary tube. So as the countering forces depends on the density of the sample, so the sample will be contains mass into gravity. We all know that the mass is equals to volume into density. So in place of mass, we can consider this volume into density, and as usual the countering force, that is gravity. Here this volume, we can write the volume as the area into height. So let us substitute the volume factors into the above equation. Now this equation can be written as area into height into density into the gravitational force, that is countering force. So in the mathematical representation, area can be written as A h in perspective of height, density is rho, countering force or gravitational force will be written as g. So the equation or formula for the area is pi r square. So we can submit this a value into the above equation. Now pi r square into h rho g. This can be considered as equation number 4, and this is happens at downward direction. So this downward and upward both direction force will be actively participates in this capillary raising method. So at equilibrium state, the upward force A should equals to downward force, that is B. So A is equals to B. So we have A value from the above equation, gamma 2 pi r, B value pi r square h rho g. Now these equations will be written as like this: pi r square h rho g, pi gets cancelled, r and here one r gets cancelled, so remaining gamma 2 is equals to r h rho g, and gamma can is equals to r h rho g. By using this equation, we can calculate surface tension of sample or liquid by capillary rise method. This is in detail about the capillary rise method, and let us discuss another method of determination or measurement of surface or interfacial tension, that is Dunoy ring method. Dunoy ring method. So this Dunoy ring method is also known as ring detachment method, and also known as tensiometer method. In this Dunoy ring method, the principle involved is the force needed to lift from the liquid is directly proportional to the surface tension or interfacial tension which is created by the liquid or sample. It is very simple to understand. The force is equals to or directly proportional to the surface tension or interfacial tension which is created by the sample. Based on this principle, the Dunoy ring method is going to work. And here you can see, in this we'll be having a ring. This is the ring portion, this is ring. This ring is made up of platinum or stainless steel. Especially it is made up of platinum or stainless steel because to avoid corrosion. This will be the sample or the liquid, which is sample or liquid. This ring is attached to a dial reading. This is the dial reading. Also known as tensiometer. So this ring is directly attached to this dial reading or tensiometer. When the liquid is contact with the ring portion, then immediately that will be impacted by the surface tension or interfacial tension, and that reading will be calculated by help of this dial reading or tensiometer. Based on this principle, this denoising method is going to work. Let us discuss the in detail process of the denoising method. So first thing we need to do here is clean the ring, and the next step, dip it into sample. After dipping, now detach the ring from the sample. After detaching the ring from the sample, now we can calculate the surface and interfacial tension from the dial reading. This can be calculated at two parts. First part is upward direction of ring. The second part is downward direction. This upward direction happens when the ring is detached from the sample. This downward direction occurs when the ring is dipped into sample. So let us see again what will happen at upward direction and what will happen at downward direction. First thing is at upward direction. So when the upward direction is done, then we can take the readings directly from the dial reading which is attached to the ring, This dial reading is also known as tensiometer, as we discussed in the principle itself. So at this dial reading, we will get the readings as A is equals to dr. Let us consider this is equation number 1. Let us see what will happen at downward direction. So this downward direction happens when we are trying to dip the ring into the sample. At downward direction, point B, here B value will be 2 pi r. As we know that the ring will contains two circumferences. This is inner circumference and this will be the outer circumference. Hence this can be written as 2 pi r into 2. This 2 is from the two inner and outer circumferences. So finally this can be written as 4 pi r. This is considering as equation number 2. At equilibrium state, this upward direction and downward direction should be equals to each other. So A and B both are equals. So dr should be equals to 4 pi r. So finally the surface tension of a sample, that is gamma, can be calculated by this formula, that is dr upon 4 pi r. This is about the denoising method. And next method, that is drop weight and drop count method. This drop weight and drop weight method is also known as stalagmometer method. Stalagmometer method. This stalagmometer method or drop weight and drop count method is works. The principle involving in the stalagmometer method is the sample needs to suck up to mark A, and after sucking need to allow the sample to flow down up to the lower mark B in the stalagmometer. As stalagmometer consists two marks, mark A and mark B. This mark A is considered as upper mark of stalagmometer, and this mark B is considered as lower mark of stalagmometer. This is the stalagmometer. This stalagmometer consists upper mark, this is upper mark, and B is lower mark. Here we have a bulb. This area is a bulb, and we will be having capillary tube. At the base of this capillary tube we have a small capillary or hole. By this we can suck the sample up to mark A. This is the principle involving in the stalagmometer. Let us discuss about the process of the drop count and drop weight method. So in this, the first step, again we need to clean the stalagmometer. After that, suck the sample up to upper mark A. After sucking, now allow to flow down up to the lower mark B. Now calculate the surface tension of the sample in two different methods. First one is drop weight method. Second one is drop count method. Drop weight method. In this drop weight method, we need to compare two samples, sample 1 and sample 2. So in case of sample 1, that can be written as W1 is equals to 2 pi r gamma. So the gamma 1 can be written as W1 upon 2 pi r. Let us consider this is equation number 1. Next, in case of sample 2, so here the W2 can be written as 2 pi r gamma 2. So this gamma 2 can be written as W2 divided by 2 pi r. Let us consider this is equation number 2. Now we need to compare the equations 1 and 2. Equations 1 upon equation 2. This can be written as gamma 1 divided by gamma 2 is equals to W1 2 pi r get cancelled, gamma 1 upon gamma 2 W1 upon W2. So we need to calculate the surface tension of sample 1. Then this can be written as W1 divided by W2 into gamma 2. Based on this equation, we can calculate the surface tension by drop weight method. drop weight method by using stalagmometer. In case of drop count method, in this method, as we discussed, here we can be having a bubble, and this will be attached to a capillary tube. Here we have upper mark, and here we will be having lower mark. This is the capillary. So drop count method. So initially we need to suck this sample through this capillary up to mark A, and now after that we need to allow the same sample to reach up to mark B. So in this case, while it is reaches to mark B, and it will starts to come out from the capillary tube itself. So now the drops will be flows down by crossing the lower mark. So we need to calculate the drops. During this process, the gamma value will be written as W into G, written as W into G divided by 2 pi R. During this, we can write the gamma value, that is W into G 2 pi R into eta. So here this eta indicates the viscosity of the sample. So based on this viscosity, the number of drops will be decided. As we know that W is equals to density into volume, so gamma is equals to density V, that is volume, into G 2 pi R eta. The same process can be done in two different samples because we need to compare the different samples. In case of sample 1, that is gamma 1 can be written as rho 1 V1 G divided by 2 pi R eta 1. In case of the sample, the gamma value, that is gamma 2, can be written as rho 2 V2 G, that is gravitational force, and divided by 2 pi R eta 2. Let us consider in case of sample 1 is equation number 1, in case of sample 2 equation number 2. Now we have two gamma values at sample 1 and sample 2. Now let us compare these two different samples values. Here in case of sample 1, the volume 2 pi R, gravitational forces will be constant. So this equation 1 can be written as gamma 1 is equals to rho 1 divided by eta 2. In the second case also, volume 2 pi R G can be constant. So this can be written as gamma 2 is equals to rho 1 divided by eta 2. Now we need to compare these two equation 1 and 2. Then it can be written as so to know the surface tension of the sample, by using this equation we can calculate the surface tension of the sample by drop count method. This is about the stalagmometer method or drop weight and drop count method. Let us discuss the another method of measurement or determination of surface or interfacial tension, that is bubble pressure method. In this method, we are going to use two different capillaries whose radius is different. So these capillaries can be considered as capillary A, capillary B. Capillary A can be considered as narrow capillary, wide capillary. In this method, when the capillaries are introduced, in this method we will be having two different capillaries. This is capillary B, wider capillary, and this is capillary A, narrowed capillary, and the major difference in between these two is radius. In capillary A we have small radius, in capillary B we will be having larger radius. So these capillaries are attached to a manometer. This manometer is used to measure the pressure differences, and also the same capillaries are attached to a mercury reservoir, and this mercury reservoir is used to find the bubbles. Based on these bubbles we can calculate the surface or interfacial tension of the particular sample. In this bubble pressure method, let us discuss the process, how it will be works. First, insert the capillaries, both capillaries A and B into the sample, and then attach the chamber to mercury reservoir, and the same chamber should be attached to manometer. Here at this manometer we can calculate the pressure differences which is created through the capillaries, different capillaries we have in the chamber. After this, the mercury chamber will create some bubbles initially when the capillary B is opened. At this time capillary A will be closed. Now close capillary B and open capillary A. Because of this process we can find some bubbles due to the pressure differences in the capillaries A and B. Now note down the readings of pressure differences, delta P values from manometer. After this we can calculate the surface tension or interfacial tension by following formula, that is AP into 1 plus 0.67 R2 dP upon R2 D upon P into G. By using this equation we can calculate the surface or interfacial tension by using maximum bubble pressure method. In this, A is apparatus constant, P is pressure value, that is delta P value, which we can get from the manometer. Here D is the density of the sample. Already we discussed how we can measure the density by help of pycnometer or by help of gravity bottle. We can determine the density of any liquid sample. This is in detail about the maximum bubble pressure method. Next, last method of the determination of surface and interfacial tension, that is Wilhelmy plate method. In this Wilhelmy plate method, again it is quite similar to the denoyering method. So here we are going to use a triangular plate. This method is majorly works on the principle called the force which is required to remove the plate from the sample is directly proportional to the surface tension which is created by the same sample. Based on this principle, Wilhelmy plate method is going to work. Let us discuss the in detail process of Wilhelmy method. First, we need to dip the plate, and that plate should be in triangular shape. When the plate is dipped into the sample, then now the plate will contact the sample. After 2 to 3 minutes of time, we just need to remove the plate from the sample. When we are remove this plate from the sample, that means the plate will comes to its original position. Now we can calculate the surface tension of liquid or sample by following formula. That is gamma is equals to, in this L is length, T is thickness of the plate, W is density of sample. So dear students, these are the different determination or measurement methods of the surface and interfacial tension. Hope you understood. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.